Now we will do the same problem of our previous class using superposition theorem. In superposition theorem, we will consider each active source one at a time and we will deactivate the rest of the active sources. For instance, in this problem, first we will take or consider only the 30-volt voltage source and deactivate the current source. How to deactivate the current source? By open circuiting it. So we have open circuited the current source and the current flowing through the 30 volt due to the 30 volt voltage source is I1 in this 10 ohm resistance. See the direction of I1 I have taken opposite to IL. We will consider it in the last step. Okay. Uh, so if need to find out I1 from this circuit. So what is the equivalent resistance of the circuit? It is this 5 and 10, they are in series, right? And this 5 and 10, after they are in series, they are the combination is in parallel with this 5. So parallel 5, and this whole combination is again in series with this 15 ohm resistance, is in series with this 15 ohm resistance. So this is R equivalent, and the value of this R equivalent, if you go calculate, it is coming as 75 by 4 ohms. It is coming as 75 by 4 ohms. So what is actually the total current? Total current I is equal to 30 divided by 75 by 4. 30 divided by 75 by 4, which is coming as 8 by 5 ampere, which is coming as 8 by 5 ampere. Now the current small I1 which is flowing through this 10 ohm resistance, this I1, it will be divided into, this capital I is divided into two parts. One is I1 which flows through this 10 and 5 ohm resistance, and another flows through this 5. So the value of I1 is the resistance opposite 5 divided by 15 plus 5, 15, this is 10 plus 5, 15, 15. The equivalent circuit, if you want me to draw, it is like this. This is 15, this is 5, this is 15 again, and this is 30 volt. Okay, so the current through this 15 is the same current that flows through 10. So if you want to find out this I1, by the current division rule is given as, this is 5, this is 5, is given as 5, this 5 divided by 15 plus 5 into the total current. What is the total current? 8 by 5. So you get 2 by 5 ampere. Now this 2 by 5 ampere is flowing opposite to IL. So we will just remember it, or if you can want to find, yes, just remember this I1 is in opposite direction to this IL. Now to remove this and just remove this. Now see, I have short circuited the 30 volt voltage source and we are considering only the current source. In the next step, we have short circuited the voltage source and we are considering only the current source. This is, let this be I2, right? So with this, you see from this diagram, this 15 and 5 are in parallel, right? 15 and 5 are in parallel. So 15, 5 parallel, you get 15 and 5 parallel, you get 75 by 20. So the next circuit is like this. This is 75 by 20. This is in series with 10 and this is 5. This is 5 ampere, you know. So This 75 and by 20 plus 10, they are in series, right? They are in series. So the next circuit is like this. So the next circuit, it becomes like this. This resistance is 75 by 20 plus 10. And this is 5. So this 75 by 20 plus 10, it comes as 55 by 4. 55 by 4 ohm. So now if this is 5 ampere and you wish to find out the current through this 10 ohm resistance, right? So this is the current which flows through this 55 by 4 ohm resistance. So this I2 is equal to 5 opposite resistance divided by sum of the two resistance, 5 plus 55 by 4, 5 plus 55 by 4 into 5. And if you solve this, you will get it is coming as 4 by 3. 4 by 3. I2 is coming as 4 by 3. So this I2 is due to 5 ampere volt current source, and I1 was equal to 2 by 5, and but it was in the opposite direction. Remember, I1 was in the opposite direction. So IL, final value IL is nothing but I2 minus I1, because the direction of IL and the direction of I2 were same. So this is equal to 4 by 3 minus 2 by 5, and that is again coming as 14 by 15, which is same as 28 by 30, which is same as 28 by 30 ampere, which was our earlier result. I hope you understood this problem. And one current division rule, let me clear your current division rule doubts if you have any. Suppose this is a circuit. Suppose this is a circuit. Suppose this is a circuit. Current through, if this is R1 and this is R2, and this total current is I, and this current is I1, and this current is I2, then I1 is equal to R2 by R1 plus R2 into capital I, and I2 is equal to R1, the opposite resistance, divided by sum of the resistance R1 plus R2 into capital A. So you remember this while doing problems. Okay. That's all for today. I will solve the same problem with the Thevenin and Norton in the next class.